Should we start? Okay, so
One moment, please. Okay, teacher Sad. Please can we start right now?
okay, all right.
Thank you.
Okay, so today we are having the things that we are learning is prisms, then something with the cylinder, then volume of prisms, area of the prisms, and some practice questions. All right, so let's say the first thing is, what is a prism? Okay. A prism is a solid shape that is bound on all sides by the plane faces. Let's say, like, for example, let's say I have a triangle here. And I have another triangle which is here. Okay, and then I join them by the lines like this. I join them by the lines like this. Then this thing, which is like a tent or something, this is a prism. It has some, this is the base, the same sides, the faces, they're also called the faces, or you can say the the bases. All right, this one and this one. There is two sides that are same. There is two sides that are same shapes, and then they are joined by the straight lines like this. Okay, so prism is a solid shape that is bound on all sides by the plane faces. So this one is a face, right? This triangle is a face. Okay, so the front one is a triangle which is a face. The right side one is a rectangle. If you see, it's like this. This one is also a face. Okay. Similarly, the back side end is like this. That's also a face, right? So it's bounded by the faces. These are all called the faces. Okay. So there are two types of faces in the prism. The top and the bottom face are identical and they are called the bases. So for this one, the one that I draw, the triangles, these triangles are the bases for this prism. A prism is named after the shape of the bases, right? So this one has, the one that I draw have the triangles. So it is a triangular prism. We call this a triangular prism because the sides are the triangles. If a prism has a triangular base, it's called a triangular prism, like the one that I have drawn. So these, okay, so you can see the shapes here, someone else, like this one is also a prism, this is a prism, right? This one is prism, this is also a prism. These are all because the top and the bottom, they have the same shapes. You cannot see, but like, let me, if I can draw it for you, like this one is like kind of joining like this. So it's a five-sided. So five side is called the pentagon. So it's a pentagonal prism. Okay. The face other than the top and the bottom one of the prism are called lateral face. Let's say I had a triangle like this, and the prism was and the sides were like this, and then there was another triangle at the other end. Let's say like this. There was a triangle like here, there. So like there. So the triangles were the bases because there is two identical bases of that. But this one is called the lateral face. This one is the lateral face. So all the lateral face are also identical to each other, and they belong to the class of the parallelograms. So the lateral faces that we can see, they're also identical for the face. Like this face is a parallelogram. This one, the other one, which is on this side, that will be like kind of here, the one at the bottom, right? So all of these, they are also called, they are the lateral faces, and uh, they are also sometimes they are parallelograms. That means that the lateral face can either be a parallelogram, rectangle, or even square, since all of them have their opposite sides parallel to each other. So the lateral faces can be rectangles, squares, parallelograms. Okay, so like that. One of the most common example of prism is a cuboid. It is a rectangular base and it's called a rectangular prism. So cuboid means a cube. Okay? So let's say I have a square here. I have a square here on one side, and I have another square here on the other side. Then I join them with their lateral like this. Like this. Okay. So this one is a cuboid. This one is a cuboid. So this one is called a cuboid. It is called the rectangular prism. This one is called rectangular prism because the base of these ones, the base of these ones is the rectangle. You see, this is a rectangle here, the base, and this one here is also a rectangle.
Pero le encontró con la mano, por eso se puso curiosa.
Okay, next is the elements of the prism. A prism can be labeled with its features, which help characterize them. Edge. Okay, so a straight line that connects the two adjacent vertices of the prism is the edge. Like this one is an edge here, like this one is an edge, this one is an edge, this is an edge. Okay, so the one that connects the two vertices is an edge. Right? The straight line, okay, so that's an edge. The corner of the prism where any two edges meet are the vertices. And okay, face is a closed thing, right? This anything which is closed, flat surface surrounded by the vertices and edges. Okay, it's surrounded by the vertices and the edges, and it's a closed shape that is called the face, like the one that we had drawn before, this one. If you want to see how many faces it have one, two base faces, and 1, 2, and 3 lateral faces. Okay, now the next thing is the cross section of a prism. The cross section of a prism is the shape obtained when a plane intersecting a prism along its axis. Based on the shape of the base, prism can be categorized into following. Okay, so now, like let's say this is a prism that I have here, and let's say if I cut it through a plane, let's say this is a I'm trying to like not very good with the drawing. We'll try. So let's say I have here is a plane, or you can say it's like a blade or something which cuts it from here. Okay, this I cut this. When I will cut this, so the thing that it will cut out will be a triangle. It will be where this blade is cutting is it will cut out a triangle. It will cut out a triangle. So that triangle is like, that's the cross section. That's the cross section. Like when we cut it out, this section that we have got here is the cross section. Okay, so now we are naming them, categorizing them on the name of the base, the shape of the base. So this one is a triangle. The shape of the base is a triangle here. See, this shape is a triangle. So this one is a triangular prism. Next one is a hexagon. So the one with the six sides, the one with the six side is called a hexagon. So it has six sides on the top, six sides at the bottom, like this. It will be like kind of.
One question, is this geometry? Teacher,
Yeah,
is this
it's the
geometry?
these topics are from geometry. Yeah, yes.
Okay, thank you.
So this one is a hexagonal prism. Okay, and then the next one, this one is a square prism because the tops are the squares. The tops are the squares. So it's a square prism, and we also call it a cube, right? This one is also called a cube. Okay, so the next one,
Of which level is this class?
this is mixed, and we have to like it's about the topics for this one is introduction to prism and cylinder. Okay, introduction to prism and cylinder, their volumes, their areas, and some applications for
So
that.
it's 9th or 10th grade, or which grade is it?
Yeah, around there, maybe. It's not too advanced.
Okay, thank you.
Okay, so this one is like the pentagonal prism, right? This one have 5 sides, and then it's a pentagonal prism. This one is a rectangular prism, like the one that we saw before. Okay, so next thing is regular and irregular prisms. There is, if the shape, the regular means if the base of the thing is regular, right? Like this. If the base of the thing is regular, regular means all the side lengths are equal. They have the same angles. These angles, these side lengths, they are equal. Then they are the regular. But this one, like this one, this length is smaller than this length. This one is smaller than this one. So this one is an irregular prism because the shape, the base that on which we are making the prisms is not regular shape. This shape is not like the shape we have like this is not a regular shape. But if we have something like a square, it's a regular shape. Triangle is like with all the side lengths equal is a regular. Like pentagon is a like if we have hexagon like this, it's a regular. So these ones are the regulars in which all the side lengths are same, the angles are same. So these are the regular ones. And the one that they are not same, they are called the irregular prisms. Okay, so the next one is the right prism and the oblique prism. So a right prism will have two flat ends, right? The first, it's a flat end here, this one and this one, they will be flat ends, right? So because the angle here, this angle here formed, this angle formed here will be a 90-degree angle. This angle formed here will be a 90-degree angle. But let's say it's like this now. Instead of this, it's tilted. It's not kind of tilted just like that, but the above side and the lower side is no. This one is it can be regular. Because this shape is regular. It depends on the shape of the base, the side lengths of the base. And the side length of the base is same. If this is a regular triangle, like the triangle, it's a regular shape, it's a regular. It does not matter. The oblique and the other one means this angle, that the angle formed will not be 90 degrees. That's the difference. Like this angle here is not 90 degrees. This is not 90 degrees, but in this case, this angle here is a right angle. It's a 90-degree angle, but this one is not a 90-degree angle. So that's not a regular one.
How many degrees is the oblique?
Oh, it doesn't matter. If it's not 90, it's oblique. If it's 90, then it's a special case. That is the right one. It's just the right prism only if it's 90 degrees, and the sides are the parallelograms. If it's like the flat edge is the 90 degrees. If it's not, then it's an oblique. Okay, so next thing is the surface area of the prism. So we try a question. So that okay, so let's first see the formula and then we will try the questions. So surface area of a prism is 2 times the base area plus the base perimeter times the height. So let me start with some basic example with a triangle. So let's say we have this. We start with the first one, the triangular one, right? Oh, sorry. Yes, so this is the triangular one. So let's say this is 8, all right? And let's say this is 7. And we have the height here. Let's say this one is 4. So, and let's say we have this height. And let's say this height is, let's say, 6. Okay, this side length is 6. This one is 6. Okay, this one is also 6. Let's say this is 8, and this one is, let's just assume it's 4. This one is 7, and this one is also 7, and similarly the back one is like that. Okay, so we want to find the surface area, the area of the surface of this tent type shape, the rectangular prism. So what we need to do is, we have 2 bases. There is 2 base faces, 2 triangles. The one is 8 and the 4, like this. So we can find their areas by using the triangle formula, 1/2 times base times height. So we will get 16 for one triangle, but there is 2 triangles, so it will be 32 units. 32 units for the base faces. Now we will do the lateral one, the lateral face. So there is 3 lateral faces, but those are the rectangles. So these are the rectangles, and the area for the rectangle is this. Like if you see, it will be like kind of like this. This is 7, this is 6. So we want to find the area for this thing, which will be 7 times 6, that is 42. So that will be 42 units. So 42 units, but 42 units for one side, and there is 3 of them. There is 3 of these sides. Okay, so we can multiply it with 3, that, and then add them. So this will give us the area. There is another method. That we can use. Is, instead of doing this, let's just find. Okay, so we have the base areas. That's 32 units. Now, instead of finding the areas of the lateral faces, what we do is we find the perimeter of the base. Okay, so the perimeter of the base is here, like this. So the perimeter for this base is 8. The perimeter for the triangle is 8 plus 6 plus 6. Then it will be 20. So the perimeter for this one is, this side is 20. You find the parameter. Okay, look, base parameter times the height. Height, we consider this length, this 7, as the height. You can say it's length or you can say it's height. It does not matter. But it's the distance from one base to the other base, like that. So we do it. So that's parameter. Okay, so now this is the base, the area of the base, 2 times the base area, that's 32, plus base parameter, which is 20 times the 7. So 32 plus 140, that will be 172 unit squared. So the surface area for this rectangular prism is 172 units squared. Okay, so next one is the volume of the prism. Okay, so to find the volume of the prism, what we need to do is, let's say we do it with the let's say we do it with the pentagonal. All right, let's draw a pentagonal. So this here. So just like it will be like, well, just wait a second. Let me just try to draw it again. Sorry. Let's have one pentagon. Let's have another one here, like this. Okay, let's now join it. And let's assume that this one is a regular pentagon, and let's say the side length for each side is 7. Let's say this is 7. So let's say I have a regular pentagon here, kind of. Its side length is 7. Each of them is 7. All right, and let's say let's say this is the center, yeah, from there. So let's say this distance from there to there, this distance is 4. This one is called apotheum. This distance is called the apotheum, like this. The center distance is called apotheum. That's represented with A. And this one is 7, so it's 7 for all of them. Every side is 7. So what we need to do is, we need to know the area of the base times the height. Let's say this height is 10. This height is 10. But first we need to know what is the area of this pentagon, regular pentagon. What is the area of this one? So to do that, there is different formulas, but the one that I'm using for this scenario is, it says 1/2 times the apotheum, its height. The height from the center is the perpendicular distance to the any line, any outer edge. From center to the any outer edge, the perpendicular line down there is a apotheum times the parameter P times the parameter. The parameter for this one will be, okay, so there we need to find how many sides are there. Okay. 1, 2, 3, 4, 5. There is 5 sides. So that means the parameter of this one will be 7 times 5, that's 35. And the apotheum for this one is 4. And we're doing 1/2. So that's the base area, or the area for this pentagonal base. So that will give us 2 times 35, that will be 70. So now we have this one is 70, but the formula tells us the area of the base times the height. So we have the area of the base, is equals to 70, and the height that we're having is equals to 10. Right? So volume will be equals to 70 times 10, that will be 700 unit cubed, 700 units cubed. That will be the volume for the prism. Okay, we have another question. Let's say here, calculate the surface area of the prism with the base area 25, a base parameter 24, and the height of 10 centimeter. So we want to find the surface area. So the formula that we did for the surface area was 2 times the base area, 2 times the bases, whatever the bases are, the end, plus base area times the perimeter. Oh, sorry, not the base area. My bad. That was base parameter times the height. Okay, so what we have here is we have the base area of 25. It's 25, so 2 times 25, and then perimeter of 24, so 24 times 10, which is there, just like that. So it will be 50 plus 240, so that will be 290. So unit squared, because it's the area, so area will be in the unit squares. So that's how. Okay, so this is a, we didn't know what kind of prism it was, what was its base, because what we did, we already know the area for it, so we didn't have to find the area for the base. Okay, so next one is a cylinder. Okay, a cylinder is a 3D solid shape that consists of 2 identical and parallel bases linked by a curved surface. Okay, these bases are like a circular disc. The line passing from the center of, or joining the centers of the 2 circular bases is called the axis of the cylindrical shape. The distance between the 2 bases is the perpendicular distance and is represented by h. The 2 circular bases have a distance from the center to the outer boundary, which is represented as the radius. Okay, so a cylinder is basically the combination of 2 circles and 1 rectangle. 2 circles and 1 rectangle. Let's see how we can make it. Let's say we had 2 circles. Circle 1, and this is our circle 2. All right. So, and there is a sheet. There's a sheet, or you can say rectangle. There's a rectangle or a sheet. So what you can do is, what you need to do, you need to roll this sheet. You need to roll this sheet, and you need to, this side and this side, you need to glue them together. You need to identify them. Like you make them same, you make them ones. Okay, you glue them together. Whatever the points that are on this edge, you make them same. Like if, let's say what we do is we combine them. So let's say if someone is here, okay, it's the same point. If you are here, then technically you should also be here, because you have joined, you have to join them, you have to glue them together. So what you do, you roll it, you glue them, you roll it, you glue them together. Once you glue them, it makes a, just like if you have any of them, you have the pages, if you roll it and join the ends, it makes a curve. All right, and then on the open ends, you put 2 caps, right, like this. These are the 2 circles that you close it with. So like the example for the cylindrical shapes are pipes, fire extinguishers. We also have like the water tank, cold drink cans, right? So like that. So most of the things that we use, like they are cylinders, they are cans, cylindrical cans, for the cold drinks, for anything else like that. Okay, now there is some types of the cylinders. The right circular cylinder. If the axis of the two, yeah, like a can of soda, exactly a can of, like, it have a lid on the top. Let's say that it's have a top lid right from where we open, and then it have a circular sheet, okay, like this. It's a circular sheet, and then it have a base. Base is also a circle, like this. So that's a cylinder. Okay, now next one is a right circular cylinder. If the axis of the two parallel bases is perpendicular to the center, let's say this is a base which is a circle, this is a base which is another circle. These are the centers. Then you draw the line from there to there, and if this angle here and this angle there with the let's say this is the radius, okay, if these are the 90-degree angles, then we call them that it is a right circular cylinder. This one is a right circular cylinder. Okay, let me show you the example here. Okay, so the first one, you see the first one, it's a right circular cylinder. Let's say this is the center of this one, this is the center of this one. Then we join them, so the angle is 90 degrees with this and this. Then it's a right circular cylinder. Next one is an oblique cylinder. Next one is an oblique cylinder. So an oblique cylinder is the one whose side can lean over the base. No, not because it's straight. Right, when we are saying the right, it means the 90-degree angle. Right angle is called the 90-degree angles. So all this right means 90-degree angle. Right angle is a 90-degree angle. The angle between the like if this is the circle, this is its radius, and this is the axis. This one, if this angle is 90 degrees and this angle is also 90 degree with the above one, then it's a right circular cylinder. Yes, this one is the oblique one, is the one whose sides lean over the base. Let's say this is the one base, it has like this, and there is another base up there, let's say this, and it's joining it like this. So it's not straight. This one is not straight. It's like this angle is not 90 degrees. This angle is less than or more than whatever, but this angle is not 90 degrees. Then it's an oblique cylinder. The next one is an elliptic cylinder. A cylinder whose basis is form of an ellipse. Okay, there's a difference between a circle and ellipse. This is like an ellipse. Ellipse have two, like this distance is more, this distance is less. They are not equally distant from the center. All the points are not equally distant from the center. So this one is an elliptic cylinder. And then the right hollow cylinder. Okay, so let's say if we might have seen something like that. There is let's say there's a shell, or it's like this. Let's say the center part is empty, the center part is hollow, and then like this. So this one is a hollow cylinder or a cylindrical shell. Okay, it's like, you can think of it like a pipe, something, because it have some thickness. You see, it have an outer layer, inner layer, and then from inside it's empty, like this one. The inside is empty, like like if you have water or something, let's say the outer side is solid, it's solid, this one is solid, this is empty, the inner side. So you can, like, the water can pass through it, anything can pass through that. Okay, so this is like a shell, cylindrical shell.
How many degrees does a cylindrical shell have?
Although it doesn't have to, like, it's a right, this one is a right cylindrical, because this angle is right, this angle is 90 degrees here. If this angle is 90 degrees, this one is 90 degrees, then it's a right cylindrical shell. But if it is similar to like the above one, let's say I make a hollow circle here in this one, then it's an elliptical, oh sorry, this is an oblique shell, this is an oblique cylindrical shell. So if it's just 90 degrees, then you call it right cylindrical shell. If this angle, the axis, this angle between the axis and the radius is not 90 degrees, then you call it an oblique. Okay, so the formula, this is the formula for the
Cylinder.
okay, so the volume of cylinder. Okay, now let's see how we can find volume and then total surface area. So for the volume, what we do is we find the area of the one disk like this. If you think the volume is like stacking up, let's say, I don't know if you have seen like the let's say we have the disks, right? Let's say these are the solid disks like that. If you stack them one after one, same on the same center, you keep stacking them, right? They will make up a solid thing like this. Let's say this is a solid, it's all filled, right? So it took some space, it covered some space, right? It have a volume, it covered some space, so that's the volume. So what we do is, basically, if we know the area of this thing, the thing on the top,
So it's height plus radius.
yes, so this one is the top, so pi r squared, the area of the top is pi r squared, pi times the radius squared, because it's a circle. If we know this area, then what we do is we can just stack them. In mathematically, ideally, we say that this disk, this is a circle, it have no thickness, its thickness is 0. Then we multiply it with the height, this height, how much height is it? If we multiply it with this height, then it becomes the volume. And to find the surface area, again, it's the similar thing. You have two circles, one at the top, one at the bottom, and they are identical. They are identical. So if you find the area of this one, which is pi r squared, you just times it with 2. You just times it with 2, because you have two circles. This is second circle, this is first circle. And let's say you have something, but how we can find the area of this circular one, this thing? There is two ways to do that. We'll see both ways. How we can find the area, surface area of this circular thing? Okay, so there is two ways to do that. The one way is, let's get a scissor. Let's get a scissor. Let me try to draw a scissor. Hopefully I can draw it. Okay, let's take a scissor and cut it here. You cut it, then you expand it. You cut it, then you expand it. All right. It will become a sheet. It will become a sheet. The height of the sheet will remains h. The height of this sheet will be h. All right. And then can anyone like If any of you knows, what will be this much? How much will be this thing, the top one? Let's say this, I give that black color. How much will this be black? How much will be this black thing, black side? Can anyone answer that? 2? Oh, it will not be a number, it will not be a number. I'm just asking for a general formula. It will not be a number. It will be like in terms of the variables. R, it's not just the R. The R is the inside one. This smaller is the radius here. You want to try one more guess? Okay, it's okay. So this one will be 2 pi r, because this is the circumference of the circle. Okay? This is the circumference of the circle. If you see this side length, this length is the circumference of this circle. Right? And we know the formula for the circumference of circle is 2 pi r. And this length is h, because it remains the same. We did not did anything with that. So the area for this one is 2 pi r, or you can say 2 pi r small r h. Okay. Then it's 2 pi r h for this one, this sheet. All right. So this is the surface of that sheet, and we know the surface areas for the two circles. So the formula is pi r squared for the circles plus 2 pi rh for the rectangular sheet that's covering the circles. Okay, so the other way that what we can do is, it's the same thing. What we do is we find the circumference of this circle. We find the circumference of the circle, and we find the area of the circle. This is the area, 2 times the area of the circle plus circumference times height. Circumference times the height. So we can simplify. We can take 2 pi r as common. We can take 2 pi r as common. And then the inside will be just r plus h. So radius plus the height. So this is like a little simplified quick formula, and these ones are a little expanded, but they give you more idea about how we actually formed it. This one is just like, if you want to do the quick calculation, just use this. Okay, now let's try a question. Let's say I have this cylinder here, and the radius of this r is 6, and let's say the height of this one is, let's say we have 5. Okay, but now there is an inside cylinder as well. I have an inside cylinder here, 2. Okay, here is an inside cylinder. Okay. So the radius, let's say the radius of that one, the inside cylinder, inside one. The radius of the inside one is 3. This inside circle has the radius 3, and its height will also be same. Its height is
So
also,
the height is equal to 5?
yes. We can have a different height, and we can try it with a different question, but for now let's just do it with the same height. Okay. So let's say we want to find how much, let's say this is our can of soda, all right, and they are cheating with, and someone is cheating with us with keeping an empty hollow surface inside. Okay, and they put an empty sphere in, empty cylinder inside it. Okay, now we want to see how much can this cylinder hold? How much drink can this cylinder hold? So what we do is we need to find the volume of the outer one, the bigger one, and then we will subtract the volume of the smaller one from it. Then we will get the volume that it can hold. Okay, so let's say the volume of outer one will be outer one. Okay, the volume of the outer is, what's the formula that we did? We did pi r squared. This is the circle, and times it by the height. Times it by the height. So we will have pi times 6 squared times 5. So let's say it's pi times 36 times 5. So I don't know. Okay, so like 36 times 5 will be 5 times 30 is 0, and then 5. So 180, I believe it will be 180. So it will be 180 pi cubed, cubic unit cubed, because it's the volume. And let's say the volume of inside one, it will be same thing. Let's we call this the V1, and let we call this the V2, the smaller volume. So it will be pi times 3 squared times 5. So that will be 9 times, okay, so that's 9 times 5. So that's 45 pi. All right. So what's the area, what's the volume that this cylinder can hold? Because it's empty from the inside, then then we can do is 180 pi. So total volume that it can hold. Okay. Total volume that it can hold is 180 minus 45 pi. That will be 135 pi unit cubed. It will be unit cubed as well. When you're doing, it's the volume, it's in cubes. Okay, so that's how we can find. Let's say we want to make such cylinder. Let's say you want to make a drink, you want to make a soda can for it or something like that. You want to decide how much soda you should fill in it, what should be its size, what should be its volume. So you can use this cylinder formula to find that. Okay, let's see. Next is, okay, so that this is the last thing for it, which we have already kind of covered. The volume of rectangular solids, like the square. Let's say we have the square here. We have a rectangle here, a rectangle there. Here they are making the solids. Okay, like this. Okay, so like the cubes, rectangular one. So we are looking for the formula for that. So that's just easy. That's just two formulas for the volume, that is length times width times the height. Or you can simplify it further. You can say that the base is equals to length times width. The base thing of the cylinder or rectangular prism or whatever we name it is length times width. So we can have it base times height. We can have it base times height. Okay, next again is another easy question. Let's say we have a rectangular prism here. Let's say rectangle, joining them together, making a rectangular prism. The length is 8 inches. Its width is 5. Let's just call this width. And the height, let's just call this the height, which is 16. How much water this thing can hold? Let's say this is a tub, this is a box, something like that. We want to see how much water it can hold.
Are you supposed to multiply 8 times 5?
This is 5 is here on this side. This one. And let me give it a different color so you can see. This red side is 5. And so this blue side is 8. And the black side is 16. So we want to find the volume for this thing because we want to see how much water it can hold. Water takes space to be in it. So it means it needs to be find it like the volume is needed to be found. So we can do the volume is 8 times 5 times 16. Or we can just multiply this and this will give us volume. All right. So this much of water it can hold because the volume tells us the capacity of something to hold some, like hold some volume, hold some liquid, hold some drink. Okay. So this is 640 unit cubes, whatever the unit is. If we are looking for liters, then it will be 640 liters. If we are looking for milliliters, it will be 640 milliliters. And let's say how much, how much it cost to paint it if we needed to paint it from the outer side. Okay, if we want to paint it from the outer side, what we will do is we find the area of the bases. So it's a rectangular prism. Area of the bases, areas of base, area of base. Okay, area of base, that will be 16 times 5, and there is 2 bases, the front and the back. So we will, this is the area of the base, 16 times 5, that will
90.
be, I think, 80. I think it's 80. 16 times 5 is 80. Okay, so the area of the base is 80. And then what else we need to do? We need to find the perimeter of base. Okay, perimeter of base. That will be 16 plus 16, 8 plus, 16 plus 16, 5 plus 5. So 16 plus 16 is 32. So 32 plus 10 is 42. So the parameter is 42. Okay, so now let's use the formula. So we have area of base. I'm just writing AB plus perimeter of base times height. So area of base is 80 plus perimeter of the base is 42 times the 8. So 42 times 8 is 336. So what we have is like, that's 80 plus 336. That's 416 unit squared. So we need the paint is 416 unit square of paint area to paint. That's much how much we need to paint it. This is the area that we need to paint. So if we want, if like let's say there's a paint that can cover for 1 liter, it can cover 100 unit square, then we can divide it by that and we can find the paint that we need to use. All right, so if anyone have question, but I think it was basic introduction to some geometrical shapes. And if anyone have any question.
Yeah.
Mhm.
How did you get 42? Like on one of the formulas?
Here the parameter, we are looking for the parameter. This side is 16, so this one will also be 16. Okay, if this is 5, this one will also be 5. So 16 plus 16, that's 32, and 5 plus 5 is 10. So 32 plus 10, that's 42. That's the parameter. Parameter is like the boundary, length of the boundary of this thing.
But I'm confused where it says 42 times 8.
Yes, because we need to do 42, the parameter, right? Then you need to do it times it with the length, times it with the length. This length is 8. Because we want to find the surface area for this thing. This thing, the surface area
Oh,
for this.
so you added all the sides.
Yes, we've added all the sides. That's what we call the parameter. So we added all the sides. That's the parameter, and then we did it with the times it with the length. That gives us the surface area of this this not the ends, but this inside thing. The surface area of this whole thing. This thing. The surface area. This surface area of the
So
whole.
the thing on the top is the surface area, right?
Yeah, the surfaces. How many surfaces we can touch? 4 surfaces. One on the top, one on the right, one at the bottom, one at the left side.
Because it's a
This is
rectangle.
yes of the rectangular box. Okay, we are not looking at the open ends yet. The open ends, that is the area of the base times 2. Okay, that gives us the area of the base times. Oh, I think I forgot to do it times 2. Sorry. Yeah. So this was area of the base times 2. We need to do it times 2. So 2 times the area of the base, because there was 2 bases, the front and the back. 2 bases, the area of first base, second base, and then the area of the inside thing, like the thing that was there, like this thing. Like without the empty sides, the sides are empty for this. They do not have the sides, like the front and the back. The front and the back is already taken off here. And then this area is for this thing. Is it okay?
Yeah.
So basically there is
Thanks.
okay, basically there is 2 things that we're looking at. The front and the back, front and the back, and then the inside connecting thing, inside connecting thing, right? This thing which is connecting them. So this one is the area, this one is the surface area of the connecting thing, and this one is the surface areas for the front and the back. That gives us the surface area of the whole thing.
And I see that on the side, on the left corner side, on the bottom left, you wrote 1 and 2. What does 1 and 2 represent?
The first front, I can write it front side and back side. Here let's call this front side. This one front, and there's a back side that you cannot see.
So it's like a box of chewing gum, basically.
Yes, like a box, exactly. A box of juice, a box of milk, anything like that. Okay.
Okay, thank you.
All right.
Okay.
All right then.
Thank you, Teacher Sad. Thank you, guys. The class is over. I enjoy the rest of the day, and I see you next class. Have a wonderful day, Luciana, Camila, Daniel, Matthew, Lexi. Enjoy the day. Thank you so much.
Bye, teacher.
Bye. Bye, guys.